Welcome to Engineering Scale Models. I'm Jason, your host, and I do models. Welcome to part 4 of my learning to program an Arduino for some electronic projects. We're doing a traffic light project. And today we're going to talk about PWM, pulse width modulation. What is pulse width modulation? Well, you can do a function called an analog write. You write it like this, analog, let me fix that, sorry. Analog with a capital W. And you can write your pin location, so you have your pin, which will be a digital pin, and then you can set it to a value between 0 and 255. And then that will write a value or a voltage between 0 and 5 volts. So if you write 0, you'll get 5 volts. So if you go 0, will give you 0 volts, and 255 will give you 5 volts. So if you're working with an LED, you can write it at any value. And we looked a little bit at this when we did our adjustable potentiometer sketch, where we adjusted it with the potentiometer to make it dim and bright. We mapped the potentiometer, and then we used pulse width modulation to write that value to the LED. But what exactly is PWM? It is a signal. It is not a... So if you have 0 volts here and 5 volts here, 0 volts and 5 volts, and you have your scale and you have time. So if you want 2.5 volts, it's not going to write the signal high here. What it's going to do is it is going to write a signal of 5 volts, drop to 0 volts, 5 volts, 0 volts, 5 volts, 0 volts, 5 volts, 0 volts. So it's going to produce a wave like that. It's going to be a square wave, and it's basically going to turn it on and off at 5 volts and 0 volts, and the duty cycle is going to be the brightness of your LED or your 0 to 255 value. So if you have a 50% duty cycle, you're going to get 2.5 volts. So that means it is on for half the time and off for half the time. And then you can adjust anywhere in between there. So if you want higher, like 3 volts, it'll be on a little bit longer than it's off. If you want like 1 volt, it'll be off a lot longer than it's on. So that is what PWM is in my little drawing. But we're going to take a look at what it actually looks like on an oscilloscope. So I'm going to go to this view here, and no, not that view. I'm going to go to this view, and I'm going to turn on my oscilloscope. And what an oscilloscope is, it uses a set of probes, which are right here. It's a set of probes, and I'm going to hook it up, and then there's what the oscilloscope looks like. I can't get a full view of the oscilloscope, maybe if I do it like this, but I'm not going to be able to get and do my work, but we'll try this out. And right now I'm at 0 volts right here. I'm going to run auto setup just so, because nothing's hooked up to it. So what I'm going to do is, see, it's getting a bunch of noise from the probes not being hooked up. So I'm going to come back to this view and show you how I'm going to hook it up to the Arduino. So I'm going to hook my grounding pin up to my ground here, and I'm going to hook up my test probe to, I believe this is pin 9, which is a pulse width modulation pin, and you can see that by the little squiggly line there. So I got that hooked up. Now I just need to swap over and write some code here. So let's do this one. And we're going to write a quick code here. We are not even going to do the important stuff of setting the values of the pin. We know it's pin 9, so we're going to do pin mode pin 9 is going to be an output. So we're just going to declare that there. And then we are going to do a analog write, and we are going to write pin 9 a value of 255, and we're going to look at that on the oscilloscope. So let me make sure my Arduino is connected to the right port, because we all know that that gives me issues. Okay, so that is basically going to write 5 volts to the pin 9. So it's very simple. So I'm going to upload this to make sure it works. Okay, so that's working. I'm going to switch to the oscilloscope here. Okay, so let us reset it. Okay, so right there is the line that I'm getting, and it is at, so there's 2 volt intervals, 1 volt, 500 millivolts, 5 volts per division. Alright, let's do 2 volts per division, and we're at negative. Okay, so 0 is this line right here. So if I move this down, I'm going to go down to, I'm going to lower my 0. So I'm going to put this back on 0, and then I can adjust this. So there's 5 volts per division. So it's hard to see my division markers, but there's one here and one here. So I am seeing a solid 5 volts. So I'm going to go back to 2 volts per division. And now I'm going to write a different value to this LED. And watch what happens. I'm going to write 100 to the LED. So, and we'll see what that looks like. And as you can see here, let me adjust the time scale so you can see what the wave looks like. So as you can see, it is off for a longer time period than it is on. So it is on for that amount and off for that amount. So that is pulse width modulation, and I can adjust this to any way I want here. So I can do, let's do 200, and then we'll upload that, and you'll see it on the thing. So now it's on longer than it's off. So that is that. Now if I can open a different sketch here, this one. So what I'm going to do is I'm going to unhook my probes, unhook the Arduino. I'm going to plug in, let me show you what I'm doing. So I'm going to plug back in my shield here. I'm going to plug back in my shield. And I'm going back to this circuit here with the potentiometer to where I can adjust the circuit. I'm going to plug it in, and I'm going to run that old code that I ran in video part 2. You can go back and check that, but I will show you the code. This is the code right here. Again, I'm going to have to set my COM port again. Oh no, wow, I don't have to set my COM port again. That's crazy. I'm going to upload this. And then uploaded, so now I can adjust the LED and make it dimmer and brighter. So let's go back over to this view, and then I will hook this up to the ground, which is here, and I will hook this up to the positive of the LED. Okay, so now if you look at the oscilloscope, I am changing the duty cycle of the pulse width modulation until it is fully on 5 volts. So as the LED goes dimmer, the off cycle becomes longer and longer until it is completely off, and then I can go back the other way. So this is a good way to check your pulse width modulation, but this is how pulse width modulation works. It doesn't actually send the actual voltage to the circuit. It sends a pulse wave that is either on or off for a certain period of time, and therefore you can get a voltage in between 0 and 5 volts, and it does it very, very quickly. You see how fast it's moving here. Where is my time code? It's like 500 microseconds per division, so it's cranking through there pretty good. I'm not the best with oscilloscopes. I'm still learning mine, so I can't show you like measurements and anything because I haven't quite learned how to do that yet. But in future videos I'll have that all worked out, and I'll show you how that works in videos and things like that. But that is a basic explanation of pulse width modulation. You use the analog write function. We'll come back to the program here, and as you can see here, I did an analog read, and then I did an analog write down here to the LED, and then I used the value that I created from the potentiometer value to write that value to the analog write to that digital pin. I believe that is pin 11. So, and then it writes a value between 0 and 255. So that is pulse width modulation on the Arduino. It has a lot of useful functions. It works with a lot of different components. It is good. Later we're going to be looking at a rotary encoder that uses a similar technique of sending a pulse wave, 2 different pulse waves, one leading and one trailing, and I'm going to go into detail and explain how that works, because it might be added to our traffic light program to adjust the time in seconds or half seconds and things like that. But this is where we are currently. I just want to apologize if anybody watched that software interrupt video. There was some audio issues. I don't know how these audio issues happen, but they pop up, and I have no idea they're happening until the video's done and it's too late. I'm looking into it, and I'm going to try to get through that. But that's going to do it for this video, guys. You can visit me on these social media links. Be sure to leave a comment below, like, subscribe, all that good stuff. And if you could be so kind, support me on Patreon. It would be greatly appreciated. Thank you so much, and have a